Hello, welcome back. So today we're gonna dig deeper into how to build a biomechanical model in Visual 3D. So it's a little bit more than an introduction to Visual 3D. We've done that in the first tutorial. So as we mentioned, Visual 3D is a professional licensed software created by C Motion. And C Motion wiki documentation, as you see here, just has all the information you need to learn and navigate through Visual 3D. Because it is a licensed professional software, it's not open access, so you won't find all the solutions to your problems, but you'll find most of the solutions to your problems in here. But just keep in mind that you'll have to do a lot of outside of the box thinking to solve your problems and create new models basically. But before we start anything, I recommend that you check out the presentation that was made by Ben Sanderling. If you're new to the department, Ben used to be the senior lab technician at the department before he moved back to the East Coast. And the presentation that he made here just cross-references the information that are presented by C-Motion, but it's just more concise and more directed towards building a model in here. So you navigate through the Canvas course. Once you finish your training and join our department, you'll be invited by Movan Resources. So Movan is one of the cores at the Department of Biomechanics that mainly focuses on motion capture and manages all the motion capture labs at the department. So once you navigate through that, navigate through the modules until you find the Visual 3D module, and then click on the Biomechanics models full body Visual 3D. So just the basics here is that in order to build a segment, a biomechanical segment, for example, an upper body and a forearm, for example, you need at least 3 markers. So you need like the marker of the elbow and then the marker in here and then a tracking marker somewhere in the middle. Although there are different techniques and methods to create a conventional gait model, a full body model, lower body, upper body, there are not many differences between these. The main thing you need to know is, like I said, you need at least 3 markers, and that's referred to as the Helen Hayes Davis, or a 4 markers as Coda. In order to create a segment, you need to either have at least 3 landmarks. So, if you're creating an upper arm segment, you either need like an acromion marker and then a elbow marker and then one in the middle, or you can have 2 markers like an anterior and posterior marker of the shoulder, and then you create a landmark in between. Um, just like that. So it either consists of 3 landmarks or an axis, so in the middle here, and 1 landmark. So I'll let you read these on your own time to get familiar with the with how to build segments and modules. And also, when you go to the C Motion wiki page right here, you can type and ask any questions you want. So for example, if you want to build a model, just type building a model, and you can go to creating a tutorial of building a model. I just have it right here, which cross-references all the information that are mentioned on that presentation that was made by Ben. Or you can go to this link. I will provide the link on the specific tutorial. and this has all the information you want in here to build a model, and this link is very useful. So let's go ahead and start building our model. So I'm connected through VPN, that's why it's a little bit slower, but I'm recording the video through my laptop, so bear with me. Okay, so first thing, let's open up a Visual 3D, and you can open up as many Visual 3Ds as you want. I think I mentioned this on the previous tutorial, but if I didn't, now you know. So the first thing you want to do is if you go to the model panel and then create a static calibration file, hybrid model from C3D. We'll go ahead and I'm gonna actually add the model that I made from the marker set that I made for the Cobri clinical trials. So for this data, I created a hefty marker set that had 83 markers. You don't have to have all these markers. You just basically have the freedom to create whatever marker set that you want. I believe the lowest number of markers you can have for full body model or marker set is I believe 28 or something like that. So for this specific project, I created an 83 full body marker set just so I don't have to run into any risks, because we created the full body marker set. Just wait, so as I mentioned, you don't necessarily need to have all of these markers, but it is good to have extra markers in case you lose any during the collections. Because we were given and delivering clinical trials, so we have 3 sessions each week, and we gave like 12 slips per session. And we also have the wearable apparatus for slip and perturbations that is worn over the participant's shoe to induce slips in the lab. We didn't want to take a risk of losing any markers, or any data. That's why I went with this. But it's just up to you really to choose any marker set you want. So now going back to the model, just choose your static calibration, and this is what you'll have if you've never done a model, or if you don't have a model, this is what it will look like. It will take you straight away to the model section, and now you'll have to create your own models. So the first thing you'll have to do is create the pelvis segment, and for that you need to go to the segment name here. Obviously the first thing you have to do before you even create any segments is to add the anthropometric data of each of those participants. Even if you want to create the pelvis segment first, it will automatically tell you to add the mass and height. So again, if you remember, the Hennens-Hayes requires only 3 markers, while the CODA requires 4 markers. So let's start with Hennens-Hayes and create. So it'll ask you about the subject's mass. Let's just put 85 and then 175 centimeters, 1.75 meters. And here we'll ask you to add the left ACES, the right ACES, and the sacrum, because it only needs 3 markers. It only actually requires the ACES, so the right and left ACES, and then the sacrum on the back. It's just because I created their names and the marker set similar to the actual names on Visual 3D, it just makes my life easier that way, and it automatically chooses them for me. So now it's created, just click on build model, and then boom, you have the pelvis marker. The pelvis segment. But make sure the view segment is clicked, because if you don't click it, you're not gonna see the actual um, segment in skeleton. So let's delete this, and let's create the pelvis segment again, but using the coda method, and you have to always make sure you click the kinematics only. Let's create it, and again, because I made my life easier and just named the marker set similar to what Visual 3D names their markers. It just makes my life easy. Then we apply, and then boom, you have it. And that's how you start. The first thing you need to do is create the pelvis segment, and then the next thing you want to do is create the thorax or the trunk segment. Now the trunk segment is not as easy and straightforward as the pelvis or any other segment, for that matter. So to create the trunk segment, the first thing we need to do is create landmarks. So besides these physical markers that we actually place during the data collection, another powerful thing that Visual 3D offers is that it can create virtual landmarks or virtual markers that are not available, as you can see here, but are based on the anatomical or any other markers that we actually use to collect the data. So the first things, as you can see here, there's segments, landmarks, muscles, subjects, metrics. When you go to the segments, this is the panel that allows you to create biomechanical segments using the markers. But if you don't have the markers that you need, you have to first create those landmarks from the landmark panel. Because the pelvis segment here uses additional landmarks, Visual 3D automatically adds those for you. But you can create any landmark you want based on these markers. Alright, so here we first need to create the iliac markers, which are based on the pelvis segment. If you want to read more about how to create a thorax, you go to the Visual 3D tutorials that I've mentioned earlier, and just hit on tutorials modeling thorax in here, and it gives you a thorough instructions on how to build the thorax based on the ISB recommendation, the International Society of Biomechanics. It was published in Journal of Biomechanics back in 2005. So I don't specifically use all of these methods, but I do use um, a few techniques from here. Again, like I mentioned, it's really up to you on how you want to build your model. But this is a technique that was and a method that was published more than 15 years ago, so it's a little bit outdated, but it is accurate though. Alright, so what we're gonna do now is, so here what they use is they use the shoulder markers, and then the vertebra markers, and the thorax and xiphoid markers, the sternum and the xiphoid markers. What I like to use, and again, like I said, you can just read as many papers as you want, or just go in Visual 3D C Motion Wiki to learn more about it. But the way that I like to use it is just building these iliac virtual markers, and then use either the acromion marker or the shoulder joint. So we'll go through two of those and then understand it more. So to build the iliac markers, as also mentioned in this page, we'll first start with the right iliac. So you go to landmarks, as I mentioned here, landmarks, and then add new landmark. So let's just give it the same name, and then here with the starting point, I believe it uses a segment, yeah, because we already did create the segment. It just makes our life easier. And existing coordinate system, yeah. Or is it this? Let me see. All right, so you go to the existing coordinate system, and instead of the lab, you just use the pelvis. And then here in the offsets, you'll have to write this on the ML. Use this formula. In the AP, use this formula. And in the axle, use this formula. And again, like I mentioned, it's based on the pelvis segment that we already created. All right, and then we apply. All right, so the reason why that wasn't working, so if you apply here, it's just gonna tell you like failed to create, and that's because within these calculations we have the ACES distance, which is automatically created when you create the pelvis segment. As you see here, it's calculated, it's the same thing. But was missing the ACES sacrum. So the ACES sacrum here is also calculated within the subject data metrics. In here, it's a very useful tool to have, um, since you can create any new calculations that are just relative to that specific participant. Although once you have it here, it's just gonna stays. Once you have it on your workspace that is saved, it will be applied to any additional participant you apply. You add. So if you add another participant here with different masks and height, once you add the mask and height, it will calculate everything that you add in here. So because we are missing that ACES sacrum in here calculation, we have to add it. So you go to subject data metrics, add new item, then we name it ACES. Let's just name it the same way it's named. And like I mentioned, all of these are, you can find all of these in C Motion. I'm just making it easy for you to build. So then you click yes, and then you'll have it. So now when we go back to the landmarks section, we should be able to, boom, and we have it. So here's the new virtual marker that we created right now. So I have that now. So let's do the same thing for the left side. So let's just go back to landmarks, and then add new landmark, and then name it left iliac. Alright, let me do the pelvis, make sure, yep. Alright, and let's do the same thing. Alright, last one. Apply, and then now we have both. So just you always apply the changes that you made, and then build the model to refresh the model. So now we have our two new landmarks, and then we have the pelvis segment. Now to create the thorax segment, you just go back to the segment section and then click thorax, and which is the trunk. Now you have two options to create this segment. Either you use these two landmarks that we created, and if you have like the acromion marker of the shoulder, you can use that, or you can create an additional landmark between, if you have like two markers on the anterior and posterior, you can create the midpoint of that joint for each side. um, let's create it this way, and this is how it like the full body will look like. I'm just doing it bit by bit for you to follow up. So we'll just use the um, we'll use the acronym first, and then recreate the other landmarks. Okay, so hit kinematics only, then create, and then here in the proximal side you'll want to use those landmarks that we just created now. So right iliac, and then left iliac, and then here in the proximal we can use those markers. So the right acromion, and then left acromion, here we, because I use the other method like the joint, so this is how it looks like. And then depth in meter, just keep it consistent, 0.12. And we also need to create calibration markers, so I need at least 3 markers in here. We use xiphoid, sternum, C7 and C8, C7 and T8. So I believe it's here. Yep, so T8, xiphoid, and C7. And there you have it. And that way. So let's apply it, build the model, and we should be good. Now let's do the other. Let's do it the other way. Let's create a joint landmarks for the joint center of the right and left shoulder. So we go back to the landmarks section, add new landmark. We'll name it right shoulder joint center. Let me see, is it how we... Yep, right shoulder joint center. And now I believe it's just the half distance between the anterior and posterior. That's what I remember. So we chose the right anterior shoulder as a starting point. Yep, so no, this is the right acromion. So we want the right anterior yep, so this is the posterior right shoulder and then yep, right shoulder anterior, here we go. And targets of a landmark endpoint, right shoulder posterior, and we want the axle to be half the distance. We apply. Oop, nope. We need it to be offset by percentage. Yep. Apply, and that's where we need it to be. So you can see here it's just the middle distance between the anterior and posterior shoulder markers. And then we go ahead and create the left shoulder joint center. We start with the left shoulder anterior. And then target the left shoulder posterior. And then 0.5 and offset it by percentage. And we'll do the same thing for the other. Alright, so now if I go ahead and select the segments, and then if you go here and then change these to the landmarks that we just created, right shoulder joint center, and then here left shoulder joint center. Yep, and then you apply it, and it's just a little bit better. If you want to be a little bit more precise, and if you're like very visually strict, we can actually play around with these with the visual nope. Because yeah, this is not good. Just let's go back here. Right shoulder joint center, left shoulder joint center. 7. Wait, apply. Alright. Yeah, so if you want to be a little bit more like in terms of visualizations, you can go to the segment section and then click on the thorax and you go to segment properties and then modify segment coordinate systems if you want to change the coordinate systems in here. And then if you click on rotate scale graphic model, here you can like play around with it, so if you want to make it bigger, you can just make it like smaller like this. This is horizontal rotation, clockwise rotation, and then vertical rotation. um, you can increase. Here's like we're just keeping it a 1-to-1 ratio, but you can change it to like 1.2, so it's just get a little bit bigger, but obviously you want to keep it as nice as possible. And then if you want to move it, you can move it in here, you can move it a little bit because it is not connected perfectly. You can move it backward, for example, a little bit, because it is, and now it's connected perfectly. So it's really up to you, you know, but it doesn't really matter. The calculations are um, are right, so that's the main thing that matters. All right, so we have that figured out. Then we'll just go ahead and go back to the segments, and then we'll move on. So now it's up to you really if you want to like build the lower body or the upper body or the head. It's whatever you want, but these are the main first ones that you want to create. All right, so like what I'm gonna do is I'll create the head because the head is also not very straightforward. So I'll go ahead and create the head. So for the head, you can either use two joint centers, as you can see here. This is the best method I've found to with the most accurate both visualizations and data point as well. So we'll just go ahead and do this method. So we'll first need to create a landmark with the mid distance between the C7 and the sternum. So we go to landmarks and then create and add a new landmark. We'll call it mid sternum C7. Just gonna keep it consistent. You can call it any, you know, obviously you can call it anything you want, but you just have to be consistent. So we want the starting point to be the C7, then target to the sternum. Then offset by 0.5, offset by percent, and then you'll have it. So here you have it, the mid distance between the sternum and the C7. Alright, so we have that, and go back to the segments, and go to head, kinematics only, create, then here the joint center of the proximal, want it to be the mid stern C7, let's go, yep, alright. And then here, because I do have that marker that I created here, but if you use like different markers, if you have like two markers, then you have to create the mid distance in between them. But also if you create the mid distance, you have to offset the height by the participant's height. But because I have this in here, so I don't need to make my life harder, you know. So I just basically put the marker in there. To me, that's head 2. That's what I named it. Alright, now we need to put in this formula in there, and then same thing in here. And I'm gonna add this fourth marker to improve the accuracy. Anterior head, okay. Alright, there you have it. And now I'm just gonna improve the accuracy of the model by including these tracking markers. It's basically the same thing. I'm just adding the right and the left heads. Okay, right head 1. Let's go to left. Head 2. Left head 3. Okay, here we go. Alright. Okay, so it's a very big head. But where is that? I believe it's because we just need to reduce the change it to cylinder. And it has to be doesn't matter. It's probably this. Alright, so basically we just had to modify the scale. So okay, going back to the start, now just go to the segment name, head, created using that mid sternum segment, and then we use that mid head marker. You also add the anterior head, and you have to add at least 3 tracking markers. And here I'm just gonna add all of them, all of the 4 markers, but 3 is enough. For you, basically, if you just have the 2 markers in here, and then one above, it's just more than enough to build a head segment. And the last one is the right head marker. There we go. Alright, so since we have it here, we just have to go and change the scale. The data is fine, so you go to scale. It's up to you. Like I use 65 is enough, and there you have it. Alright, so now let's go ahead and create the rest of the segments. So let's start with the arm. So let's start with the right upper arm. Create for the proximal. You can use the joint center. This is for my dissertation project. I just used basically way less markers, as you can see here. So for the right upper arm, use the right joint center. We did create that, so we can use that. And for the distal, we use the elbow. So it's really up to you. You can either use the joint center, or you can use the anterior and posterior markers. So it's whatever you want. But basically it's the same calculations. If you use the anterior and posterior shoulder markers or the joint center, it's the same calculations really. You can just use the right shoulder posterior. And here we use the elbow, RABL, RABM. So the lateral and medial markers, and this should be enough. And then we use the at least one. So if you have just one tracking marker, then use that, and then the 2 other markers. Otherwise, in this case, you have plenty of markers, clusters. I believe they're called right upper. When you click on the marker, it will tell you the name. So, yep, that's what its name. Let's see. So it works fine. Just a little bit different if you use the right shoulder joint. It's probably gonna be a little bit better, but it, I meant yeah, it's the same. It's the same. But if you use the acromion instead, it's gonna be a little bit upward. But alright, so now we will go ahead and create the lower arm, the forearm, and create it. Basically the same thing. You can either create the joint center, or you just use the um, where is it? The right elbow, medial, and lateral, right elbow lateral, right elbow medial. There you go. And then here we use the radial and ulnar. So where is it? AWTR. Right wrist, ulnar. There we go. And then we add here the forearm should be yep, right forearm. 1, 2, 3, 4. Alright, now the last thing, just close all of these, we don't need them. I will do the hand, so just go ahead and add the hand, right hand, create, and here we use the right wrist, yep, should be this way, just to make sure you're correct. Right. Okay, so I use the joint center again. No, it's the same. It just depends on what do you. Depends on. I mean, again, it's the same calculations. Whether you use that joint center or just add it like this, because I believe this right wrist joint center is just the mid distance between both. So let's double check. Yep, see, I told you, it's just basically it's the same thing. So go back here, I'm gonna add here, I just add the right wrist one, and then I'll add the calculations as just the mid distance between those. Okay, and in here we'll just add those 3 markers. So right wrist 1, nope, not this one, right wrist, ulnar, radial, and apply. There we go, we have it. So now we created the right arm. We'll do the same thing for the left arm, and then we'll go to the feet. So let me just quickly do that and I'll get back. Alright, so just like that I finished the left side of the arm, so the upper arm, the forearm, and the hand. So now we have the upper body complete and ready. Now we only have the lower body to model and finish. So let's start with the right thigh. So go to the segment name, right thigh, create, and here we just use that right hip that we just made, and we'll use the mid distance between the right and left hip. And And here we need to create a landmark. As you can see here, I already created it, but a landmark of the mid distance between the uh, medial and lateral knees. So go ahead and create that, and then we add this here, right joint, right knee joint center, and then we create the half of the distance between the knee and medial and lateral, and then we create an extra target to define the orientation, a lateral between we create a lateral, and then we just add the right knee lateral, right, and then we go ahead and create our tracking markers. We add those, so it's gonna be the right good trochanter. Again, if you only have 3 markers, and then just add the right trochanter, the lateral knee, and the just that additional kind of tracking marker. And here, because I have plenty of markers, it will help a lot, with the tracking and with building the model too. So I'm gonna add the right thigh cluster, and you can go ahead and add the knee as well. Alright, here we go. We build it, and we should have a very well built thigh. Alright, so now we'll go ahead and keep going and create our, let me close this with the model, and go ahead and create the right shank. Alright, and go ahead and create it, and then here we will want to again, like do the same process. I'm gonna either add the right knee joint if you want, or just add the you can add the lateral and medial markers. Didn't we have that? Yeah, right knee joint center. Right knee joint center. Then we'll add the right ankle lateral, right ankle medial. Right, then you can just add the tracking markers. For me, I'll add the shank cluster. We have these, and also the knee and the ankle. The more markers you add, the better the model will be. Alright, we close this, and then we add the final segment, the foot, the right foot. Here we add the right ankle lateral, right ankle medial, and then here you can either add the toe or the first metatarsal, the fifth. Here will be like the metatarsal first, and here will be the fifth. Or you can add the toe in the middle. and we'll go ahead and add the tracking markers. So I'm gonna add everything to improve the, nope, not this, um, right toe, right, so I have the toe, I have the calcaneus also, and the heel. So yep, we have them all, and just also gonna add the ankle. Alright, and you should have it. So now you just have to do the same thing for the left side and we should be good. I'm just gonna add the left side real quick and then I'll get back. Alright, and there you have it. So now we have a full body marker set, full body model, excuse me. And also I went ahead and I created the virtual feet. If you want to measure the feet position on the ground, you can go ahead and create the right and left foot virtual markers, virtual segments using the virtual markers that I created on the floor level. And if you want to do that, you just go ahead and create the landmarks, the floor landmarks. So what you need to do is just keep the same X and Y of the lab, and then you offset the you offset the Z to the floor. So basically what you have to do first is create like the you create virtual landmarks from the lab, and then offset those to the ground. So here you see you keep the Z as 0. Like here the lab X is just offsetting the Y and Z as 0, and then adding yeah, 0.1 meter to the X, and the same thing to the Y, but just doing the Y 0.1 and then the Z 0.1 for the lab Z. And then here just choose that lab X and lab Y, and then the toe. So basically you keep the same position of the toe, but then you bring it down to the floor, so it's always on the floor. And then um, you build your segment using those. So using the floor offsets of those same markers. So like the ankle markers at the medial and lateral, and then the fifth and first metatarsals. Alright, and that's how you do it. Then once you finish building the model, make sure you save it. So you go to model, then save model template, then you save it, and then once you save it, you'll have to add the motion trials. So I'm gonna add like the motion trials here. Once you do, you go to model as you remember from the previous video. We'll go ahead and assign model to motion files, and then you just choose those, and then you go to the signal and events, then you choose your specific um, motion files, and there you have it. Alright, well, enjoy the process. And again, like I said, if you have any questions, you can always go back to the tutorials and see motion, and you'll have your answers there. But again, like I said, it will not answer it will not fix all of your problems, and will not give you all of the solutions, but it will give you most of the solutions, but you'll also have to keep in mind that you'll have to do outside of the box thinking. Thank you so much for listening, and good luck. If you have any questions, you can always email me and ask me. Thank you.